Welcome. So the sixth lab program is to draw a simple shaded scene consisting of a teapot on a table, define suitably the position and properties of the light source along with the properties of the surfaces of the solid object used in the scene. So first, this is a function to draw the wall. So here the input is the thickness. So first we are making use of this GL push matrix. So this is going to push what is on the top of the star, the same is replicated. Next, translated, GL translated 0.5 in x-axis, 0.5 into thickness in the y-axis and 0.5 in the z-axis. Next, scale, what is there is a scale, x-axis is 1, y-axis is thickness and z-axis is 1. That is, we have to specify the values between 0 to 1. So that is, if it is 0.5 means it is 50%, so it is 1 means that is 100%. So next, just select solid cube, that is the 1. So what is that is translated and what is the scale, that is it's going to draw, that's a solid cube. Again, pop the matrix. So this is the function to draw the wall. So next there is a table leg. So here the parameters are the thickness and the length of the leg. So again use there is a GL push matrix. So translate it, that is 0 in x-axis, then by 2 in y-axis and 0 in z-axis. Okay, GL scaled, that is a thickness. What is the thickness you specify? Next in the x-axis, length in the y-axis, again thickness in the z-axis. Next select solid cube, that is 1.0, it's going to draw one solid cube. Again call that is here pop matrix. This is going to remove the matrix from the top of the stack. So next this is a function to draw the table. Here we have parameters are that is what is the top width, next thickness of the top, leg thickness and length of the leg. Call that is GL push matrix. Translate in x-axis is 0, y-axis is leg length and z-axis is 0. Scaled, there is a top width, top width in x-axis, top thick in y-axis and top width in that's a z-axis. Call that is a solid cube 1.0. Next call that is a pop matrix. So next we have to draw that is a table. So first we draw only the top of the table. Next we have to add the legs for the table. Just calculate the distance. That is, the legs should be within the table. That's why we are going to calculate that is a distance equals 0.95. That is a 95% of that is a width divided by 2 minus leg length divided by 2. So this is distance value where there is a legs are placed. Call that is a GL push matrix. Translate in there is a distance in x-axis, 0 in y-axis, again distance in z-axis. Call that is a table leg, that is we are passing the leg thickness and leg length. So it's going to call that is a table leg function. So it's going to add one leg. Okay, so similarly translate 0 in that's a z-axis, 0 in y-axis, minus 2 into distance in that's a z-axis. Again we are going to call that is a table leg, that is second leg is added. So again translate, that is minus 2 into distance in that's x-axis, next 0 in y-axis, 2 into distance in that's a z-axis. Call that is a table leg, that's a third leg. Next translate 0 in x-axis, 0 in y-axis, minus 2 into distance in z-axis. Again draw another leg. Finally pop the matrix. Okay, so here that is we are going to add that's a table on the scene. Next, so the display solid. So here that is we have to specify that is a illumination model. So first we are going to specify there is ambient. So that is 0. RGB values we have to specify 0.7 red, 0.7 green and 0.7 that's a blue value. This indicates that is near or the far. So similarly there is a diffuse values we have to specify RGB components. Next similarly there is a specular. Okay, next similarly we are going to specify there is a shininess, that is a 50%. So next we have to add that's a material values. Okay, so here we are going to eliminate there is a GL front. There is a front face is eliminated with there is a ambient, GL ambient. What are the values which is passed in? That is a matte ambient matrix. Similarly we are going to eliminate the front face using diffuse. Okay, values are passed in diffuse array. So similarly there is a GL front, there is a specular, the values are passed in specular array. So finally there is a shininess value, GL front, GL shininess, it is the values are specified in that the shininess it is 50%. So next we have to specify where the light is. Okay, that is what is the intensity and the position. So intensity for values are that is 0.7, 0.7, 0.7, which is same as that is a diffuse, that is a ambient light. Okay, next position. This is x value, that is 2 in x axis, 6 in y axis, 3 in z axis. So this is the near and far value. Again, that is a we have to specify these values for the light. Here we make use of that is a light 0, that is GL light FP, that is we are make use of that is a GL light 0 with light up to that is 0 to 8. We are using that is GL light 0. We have to specify the position GL position. So values are specified in light position. Again, the intensity value for light GL light 0, that is we are going to specify GL diffuse, that is the intensity values. Okay. So next, GL matrix mode, that is a projection. Next is that is a load identity. So let's go to load identity matrix. So here we are taking the height is 1, that is we have to specify the values in either 0 or 1. 1 means its max value. Next, ortho, GL ortho. So here that is we have to specify that is a window, that is the x value is, okay, x value is minus window height into 64 divided by 48. So since that is we are using the window size is 640 into 480, that is we are taking the aspect ratio, that is 640 divided by 480, it is nothing but 64 divided by 48. So this is x value. Similarly, that is y value is height into 64 divided by 48. So y value, this is the width and this is the height. Okay, again we have to specify that's the near and the far values. So this is what that is a 3D. So next is GL matrix mode, that is a model view. Okay, next is GL load identity matrix. So next is lookat. Lookat position is for the viewer. So viewer is at the position 2.3 in x axis, 1.3 in y axis and 2.0 in the z axis. Where is looking at 0, that is the x axis, is looking at 0 in x axis, 0.25 in y axis, again 0 in z axis. We have to specify which is the up vector, that is 0.0, 1.0, 0.0, that is up vector is the y. Next, GL clear, that is we are going to clear the color buffer bit. Next is there is a depth buffer. Next is GL push matrix. So translate to the position, that is 0.6 in x, 0.38 in y and 0.5 in that's the z axis. Just consider as a percent. So 0 to 1 value are to specify, 60%, 38% and 50% we are going to translate, and we are going to rotate, okay, by that is the 30 degrees. Okay, here we have to specify which, that is the axis on which we have to rotate, that is x is 0, y is 1, so we are going to rotate on the y axis by using 30 degrees. Next we are going to call that is a lead solid teapot. Okay, so value is the thickness, that is a 0.08. So this is the radius of the mouth of the teapot. So next, GL pop matrix, call GL push matrix, translate 0.4 in x, 0 in y and 0.4 in z. Okay, draw the table. So what are the values passing? That is table. Okay, so that is the top width. Next is top width thickness, leg thickness and the leg length. That is we have to pass the 4 values. Okay, that is 0.6, 0.02, this is the widthness, this is the thickness, again thickness of the leg and height of the leg. Okay, so this is going to draw the table with all 4 legs, call that is GL pop matrix. Next we have to draw the walls. So that is we are going to call the wall function, the thickness is 0.2. So this will add, that is a bottom wall. Again call that is a push matrix. Next we are going to rotate by 90 degrees in x, y, that is z. We are going to rotate 90 degrees in the z axis, and we are going to add under wall with a thickness 0.02. So this is going to add, that is a side wall. Again call that is a push matrix. Next rotate 90 degrees in x axis. Okay, that is 1.0, 90 degrees in x axis and draw that is a wall with 0.0. So this will add, that is a back wall, that is a 3 walls are added. Next call that is GL pop matrix. Okay, GL flush. So in main function initialization, Next, glut in a display mode, that is we are using glut single, that is a single buffer, there is no animation. So single buffer for storing RGB components. Here we make use of elimination model, so we are making use of that's the depth. So next, window size, that is we are specify width is 640, height is 418. Next, the position is 100 and 100, that is from top, that is the left corner. Here we are going to create a window and title is simple shaded scene of a teapot on a table. Okay, and display function is display solid. So here we making use of illumination model, so you should enable that is GL lighting and that is light 0. So how that is a illumination model, it is smooth, that the shade model is smooth. Next we have to use that is GL enable depth test. Okay, so next is that is we are going to make use of the normalize. So GL create color, that is we are using that is a 0.1, 0.1, 0.1, 0.0. So it is approximately equal to that's a block, so it is going to add this a clay color. So next GLB4, that is X, Y position, width and height. So next we are going to call that is a glut main loop. It will start execute. So see, that is how it is going to display. So it is going to add first, that is we are going to call that is the table function. So it is going to add that is the table top, and it is going to add that is the 4 legs. Okay, here we are going to add one teapot with the thickness value 0.08, that is the radius of the bowl of the teapot. Next we are going to add that is a bottom wall, side wall, rotate by 90 degree. Next rotate by 90 degree, and we are going to add another wall. Okay, so it's here that is illumination. Okay, that is the shininess. So the light is somewhere here, and it is going to add that is a diffuse light to the illumination mode. Thank you.